there, so my name is Jen Odom and I'm going to be talking about forensic toxicology. Forensic toxicology is the application of chemistry, specifically forensics and chemistry, to biological specimens. That can be blood, urine, gastric contents, really any sort of bodily fluid, serum that can be analyzed. This has a lot of different applications. It's used in date rape cases, DUIs, driving under the influence of alcohol or other illegal or illicit substances, possession charges, and homicides, suicides, anything like that, where they want to know what this person had, what this person might have consumed, and the facts surrounding a certain event. Forensic toxicologists need to be well versed in a large variety of different chemistry and biology principles. They need to be able to use immunoassays, which kind of looks at a reaction between the target analyte and an antibody. Gas chromatography or other forms of chromatography, which separate different chemicals and functional groups within a sample. And mass spectrometry, which provides qualitative and quantitative analysis. Not only do they have to be able to perform these tests, but they also need to be able to explain them to a juror who might not have that background in chemistry, which is why it's very important that these people know what they're doing. Which brings me to my next point, QA/QC. A recent study, 2019, by Hamnet and Jack, looked at different problems within forensic toxicology, or potential problems. They found that forensic toxicologists have a very collaborative field. It's one of the only fields in forensics where lots of different forensic toxicologists, or even just more than one, will look at a particular sample. So it's important to keep bias away from that as much as possible. Additionally, they refer to a library, and so while it is a very objective field of science, there is still some objectivity in that they have to compare the results to a standard from a library and decide whether they match up enough. Unfortunately, forensic toxicology has gotten into some hot water, both with the Presidential Council for Science and Technology and with the NAS. Both researched forensic toxicology, and they found it wanting. This is largely because of bad actors within the forensic toxicology community. And so in order to maintain the public's trust with this field, it's very important that we follow certain QA/QC guidelines, as well as certain ethical guidelines. For starters, all forensic analysts should submit themselves to at least biannual proficiency test. This should be administered by a third-party accredited body, such as ISO, IEC. And this would just prove that the forensic toxicologist is able to perform their job. It's kind of like any other test. You have your sample, you compare it, you see if you get the correct answer. Another important element of this is making sure that your laboratories are accredited. That is, again, through ISO, IEC guidelines, and whatever is the most current guideline. I know currently we're under 17025 2017, but as that changes, so should your laboratory's guidelines and the SOP. Additionally, all forensic analysts should be and must be certified through the American Board of Forensic Toxicology. This is a certifying body. They require that before you even apply, you have a 2 to 3 year experience or a degree in chemistry or biology or a related field, so pharmacy, for example, or In my case, forensics, you could get your emphasis in chemistry or biology there. Then you have to take a written test, and if you pass the written test, congratulations, you're in, but you also need to maintain every year, show proof that you are still in school, not in school, that you are still learning, and every 5 years you need to recertify. From that, another very important element is personal protective equipment. It should always be worn. Gloves, safety goggles, lab coat, face masks where appropriate, and these need to be changed at least anytime you're handling a new sample, but also just as needed if you cross-contaminate, change your gloves, or to avoid cross-contamination, change your gloves. Also work with fume hoods if you're handling hazardous materials. Don't get it on your clothes, don't touch it, don't smell it, don't do any of that. And make sure that you are storing your samples in a cold, stable environment. Don't just leave them out. Finally, my second article is from OSAC in 2021. It is a study in Switzerland that analyzed cyanide, which is a very common ion, commonly used in poisonings, as well as accidental deaths, arson. It can be inhaled, it can be ingested, and it binds to the enzymes in our body, and it renders them ineffective, which is not good because those are there for a reason. So first they took blood samples, both known healthy blood samples as a reference standard, and then known contaminated blood samples also to reference and to test. And they prepared a stock solution, and they did several different things. First, they tried with and without a catalyzed pentafluorobenzylation. They tried it with and without a solid phase extraction step, and they tried it with and without with 3 different types of ionization techniques. What they found was actually pretty interesting. First, building off of research from 2 other papers, they concluded that the catalyzed pentafluorobenzylation was appropriate and necessary. Second, they found that the solid phase extraction process was vital to filtering out some of the things they used in their stock solution first, and then they needed to get rid of to analyze. If you didn't use this solid phase extraction step, you got a lot of funky results on your gas chromatography and your mass spectrometry. And third, they found that an NCl, nitrogen chloride ionization technique, was the most effective compared to PCl and EL. So they were able to apply this to an actual dead body who showed signs, visible signs of a potential cyanide poisoning, and they were able to determine that it was in fact cyanide poisoning and quantify how much cyanide was in the body. This just goes to show how important it is that we use best practices when we're talking about forensic toxicology. Thank you.